Hello everyone, I'm Mingxing Liu, and thanks for the introduction. And I guess I'm the only one here without a bachelor's degree yet, but I will try to get it. So the title of our paper is Identifying and Analyzing the Privacy of Apps for Kids. And most of this work was done when I was a visiting student in Carnegie Mellon University under the direction of Professor Jason Hong. So currently, the widespread of mobile phones and their rich sensor abilities has brought a lot of convenience to us, but also led to some privacy concerns. The mobile apps can get access to several sensitive private information like location or contacts or unique device ID, and some of them will implicitly send this data to far-end servers, which will cause the privacy leakage. So previous work has investigated a wide range of privacy issues on mobile apps. So our work focused on the privacy issues of mobile apps designed for kids. The reason that we especially focus on this topic is that, firstly, it is widely agreed that children are a vulnerable population, so the privacy protection is important for them. Second is that the privacy for children is less ambiguous than the privacy for other things, since there is clear enforcement and laws that regulates the behavior of the service providers. Especially in the United States, the privacy protection for children is important due to the Children's Online Privacy Protection Act, or the COPPA. It is a law passed in 1998 and has modified its content through the years. It will regulate the data collection behaviors of the online services that include the mobile apps targeted at children under 13 years old. It has very detailed and clear regulations about what kind of data they should collect and how they should tell the users about these behaviors. Currently, the role of enforcing the COPPA falls mainly to the Federal Trade Commission, or the FTC. The FTC has released several companies or those apps which recently, the FTC released two fines to two companies. These two companies design apps that allow the third-party advertisers to use the unique device ID to serve the targeted advertisement to the users, which violates the law. Also, in 2012, the FTC released two reports investigating privacy problems on mobile apps designed for kids. They manually checked the 200 apps, respectively from the Google Play Store and the Apple Store, to see if they violate the law or not. They found that the current situation was quite disappointing, that many apps will collect the data from the users, that they fail to disclose them well on the detail page or download page. So that children or the parents failed to know about such data collection behaviors before they download the app. So a general pipeline for inspecting potentially problematic apps can be derived from the method used by the FTC in their reports. Firstly, we should get a set of apps which seems to be targeting at children. The FTC staff completed this step by searching the keyword kid on the Google Play Store and the Apple Store, and just download the first 200 apps. So this is a relatively simple and faster way to get a lot of apps, but it will harm the overall accuracy. The FTC staff find that about a quarter of the apps collected this way are actually not targeted at kids. Instead, they will target at parents or teachers. So the FTC staff had to double check each app to maintain the overall accuracy. The second step is to recognize the existence of some potential data collection behaviors. In particular, the FTC cares about three features. The first one is whether the app will use in-app purchase. The second one is whether the app has targeted advertisements. And the third one is whether the app can link to a social network like Facebook or Twitter. These three behaviors are recognized as the three of the most common ways of data collection. The FTC staff checked these three things manually. Finally, we should analyze the transmission of the sensitive data when the app is launching. So the FTC staff write codes to analyze the network traffic to complete this step. So generally, the method utilized by FTC is quite comprehensive, but it is rather labor-intensive. So it will severely limit how many apps can be inspected at once and how often the survey can be conducted. So our long-term goal is to improve the accuracy, speed, and the scalability of these processes here. So in particular, in this work, we focus on the first two parts. So generally, our work can be separated to two parts. The first is that we design a machine learning classifier that can effectively identify whether a mobile app is designed for children or not. The second is that we develop automatic analytical methods to identify some privacy-related features of apps targeting children. So note that our work aims to assist instead of replacing the role of the FTC. So we aim to filter out from a million of apps to a few thousand of potentially problematic apps and help prioritize things a bit. Okay, so next I would like to introduce some technical details about our work. The first part is the design and implementation of the machine learning classifier to identify apps for kids. So generally, the way our classifier works is quite like we human beings do the classification. That, for example, there's a screenshot of an app on Google Play Store. So when we first get an app like this, we would like to first look at the title and read the screenshot, read the description, and we also like to look at the icon and the screenshots, to get the color information from it. So generally, our classifier works exactly as it is. We extract three types of features from the resources on the detail page, can be classified to the meta features, the text-based features, and the image-based features. So we put these features into the classifier and get the result. No, one thing is that in our experiment, we just use the apps from the Google Play Store, but we select the features that can be also select quite generic features so that our method can also be used in other app market like the Apple Store. So I would like to introduce these three features one by one. The first is the meta features. Actually, there are only two of them. First is the app category. So in our first stage exploration, we find that most apps designed for kids fall into one of the education, games, comics, or entertainment category. So here we use a binary feature to represent this. For each app, if we found that its category is in one of these four categories, we put the value to 1. Otherwise, we put this value to 0. The other feature here is the content rating. Google Play has 5 different content ratings. And generally, the apps designed for kids are rated as everyone or low maturity. So here we just map these 5 content ratings to its corresponding numerical values. However, in practice, we found that this feature is not quite well, since although many apps designed for kids are rated as everyone all know maturity, a lot of other kind of apps like some utilities apps like calculator or calendars, they are also rated as everyone. So in practice, this feature was pretty bad. The second type of so first we have the title and description. We also extract the strings on the screenshots to get more clues. So here's an example of the screenshot. And some words like alphabet, numbers. The words on the screenshot will also give us some clues. The kind of the content used in the app. To we put an image into the library and it will output append them into a sentence. So for each sentence, English words and also those stop words, steaming algorithms to combine the single form and the plural form of a word, like we turn parents to parent. And lastly, we calculate the TF-IDF value for each word. The TF-IDF value is an important or efficient thing to measure the importance of a word in a document. So here we, for each text-based feature, we calculate these features as calculate these values as features. So the features. So the intuition is that the picture resources of apps designed for kids typically use bright primary colors with colorful background information. We present hue saturation value or the HSV color format, and we calculate some metrics like average hue saturation brightness value and the total number of color used to get the about different colors, the proportion of different colors used in an image. Generally, these things can give us a good indication of the color used in an image. So next, I would like to talk about how we conduct the experiments to justify the performance of our classifier. We build a data set which contains 576 apps targeting kids, which is also the positive training set, and also 11,052 the negative training set. So the data collection is not as simple as it seems, since there's no criteria to determine whether an app is designed for kids or not. And here we also want to avoid the subjective judgment to avoid bias. So finally, the method we used here is to collect a list of keywords and search on Google to look at some review website and a recommendation list. So for example, we would like to search like Android apps for kids, Android apps for preschool students, and we will get some review website intended like look at the best 50 Android apps for your kids, something like that. So the collection of the negative training set is the same. So for each app, we extract the features from them and normalize them to in the range of 0, 1. We use the supervised learning algorithm. In particular, we use the libSVM to it's an open source library of support vector machine, and we use the tenfold cross validation to calculate some metrics to justify the performance. So finally, we've got 95% of accuracy and above 93% of precision and above 91% of recall rate. Generally, the performance is good here. So next, We also would like to see apply the classifier to a lot of apps. So we collect about 1 million Android apps and input them to the classifier. So, and we identified about 68,000 apps targeting kids, which is about 60.9% of the whole data set. For each app, we extracted 3 information. First is its privacy grade. So the privacy grade is a previous project in Jason's lab, and it will assign different privacy grade to an app by using the techniques of machine learning and crowdsourcing. So more details can be found on the privacygrade.org. Also, we would like to detect the 3 data collection behaviors, which is also of care of the FTC staff, by analyzing either the third-party libraries or the Android permission. We also got the app's popularity or the download volumes. So generally, the most popular apps should pay more attention. So here we would like to show some quick results. So the pie chart is the distribution of the privacy grade. We found that about 80% of apps will get A or A+, which means they have good privacy protection. But about 10% will get COD, which should be paid more attention. We also have a summary of the data collection behaviors, and that about 50% will use the targeted advertisement, and about 20% will link to a social network, and about 22% will have in-app purchase. So, okay, so let's turn to the summary. So generally, we first design and evaluate classifier which can predict whether an app is designed primarily for children, so which achieves high effectiveness, about 95% of accuracy. We also generate a long list of apps designed for children and conducted some first step privacy analysis on them. So yeah, we admit that this privacy analysis are just the first step, since for example, we just detect the usage, whether the app use targeted advertisement, but we may further look at the word content or device ID has transmitted to the fine-grained analysis. So generally, starting point for further